Java users, and I'm recording this video from Bangalore. The weather is very nice, and this is the first time I'm recording a short video. Idea is to finish the video in 10 minutes. So today I'm going to tell you some secret JVM arguments which people don't use it so often, right? So let's look into it. But before going into the presentation, I can take you to the Bangalore Jug YouTube video. Let me share my screen. Yes. So if you want to know more details about the videos that we have uploaded, these are like the videos related to the runtime compilers, and there are so many discussion happened with the module system, and there is a series of talks which we have done related to the garbage collector. You can see part 1, part 2, part 3, part 4, part 5, and many more discussing about the details of the garbage collector, right? So in today's video, I am going to show you a secret command, generally a JVM argument, and we will see like what all information it provides to you, right? So first, let me get you through a simple code. So let's see that which Java I'm in. I am in JDK 21. That's a good thing. And JDK 19 added a feature where you can do the big integer multiplication in parallel, right? So let's take that code so that we can learn two things. So um, this is a code which is into the OpenJDK. And here actually we are writing a Fibonacci series, and we are running a Fibonacci series and just doing a comparison with the number of bits it should produce. So the first piece of code which you are seeing here is actually a simple big integer multiplication, and the second piece of code which you are seeing here is actually parallel multiplication of big integer, right? So first let's see the performance, how much performance it has improved. Okay, how performant is the parallel multiplication, right? So I don't really have to do anything like Java C. I can just run a Java command, and it will take some time to get the output, because the number which we have given it to find the Fibonacci series is really big. Okay. So the secret which we will discuss today is about how to find out how much time your code has taken by the runtime compilers. Okay. There are a lot of videos on the Bangalore Jug related to the runtime compilers, but in general, there is C1 compiler and C2 compiler, which basically known as the client compiler and the server compiler, right? So we should see that how much time we are spending in C1 compiler and how much time we should spend in C2 compiler. A lot of people will hear that, okay, uh, Java runtime compiler is a beauty, but in the end, we should be knowing that what are the different optimizations that the runtime compiler is doing, and how much time my whole application is spending into the runtime compiler, right? So here is the output, and you can see it's a very big gain, right? Without parallel multiplication, we are almost spending 21 seconds, and with parallel multiplication, we are spending something like 6 seconds. And definitely the output need to be same for both the calculations. Now what I'm going to do is that I'm going to see you, let me show you how to see the time spent into the runtime compiler. It's a very simple -xx command which can tell you like it's this is a code where like I mean you will not able to see a lot of information, because it's basically a multiplication code. But when you are writing some kind of code where like a lot of optimizations happens in the code, and what kind of optimizations happen underneath, if you'll go to my Bangalore Jug presentation, you can see that. Okay, you can see into all the optimizations in probably in lot of presentations here related to C1 and C2 compilers and runtime compilers. Okay, so yeah, CI time, I have to enable it with plus. That means that you are enabling CI time. It will take again some time to get the information, and we will see a very beautiful output of how much time the code is spending in C1 and how much time the code is spending in C2. And it will also list you all the optimizations and how much time it is taken in each and every optimizations, right? So maybe the names will not be familiar for you, some names may not be familiar for you, but that's okay, we will discuss in another short video, right? So here goes the output. And I will definitely have a longer video to discuss each and every detail of it, but what you need to see is that the total compilation time, and it's about the runtime compilation. Okay, it's about the C1, C2 time. The C1 has taken like 0.186 seconds, and the C2 have spent almost 1.424 seconds, right? And you can see the lists of optimization like null check elimination, right? Like range check elimination. What are these details? We will definitely see it in some other videos, right? And C2 will have a longer list of the optimizations you can see here, right? And finally the total compiled method. And we should also look into some other video about the magic of OSR, on stack replacement, like how the stacks of C1 and C2 keep changing in between, right? So that I mean, you will never get to know on the what's going uh, underneath. It's right now running a C1 compiler or it's running a C2 compiler, right? So yeah, kind of homework for you. Just write a small code and try to look that how C1, C2 do the performance. In fact, you should also look into like what will happen if I will just run Java with an interpreter, right? um I think like for my 10 minutes video, this command may not terminate also, because the interpreter takes a long time, right? So anyway, I will just run it this I will just run it for some time and let's see. Okay. Whereas you can see like uh, the most beautiful part is that I am very impressed with the parallel multiplication, and it's like on my Mac machine, it's almost taking like maybe three times lesser. Yeah. So yes, I mean, these are all the ways to go for the Java in machine learning and making things like image processing or matrix multiplication much faster. Here also, it's a Fibonacci series, which is actually a very good code. You can grab the code in from the Java JDK source code /test, right? And let's terminate this command. It will not end for today, right? So here is the short video that why I want to record it. Okay, all the best. Bye bye.